Hey everybody, let's get some practice naming molecular compounds. And remember that name molecular, short for molecule. Molecule is the name we give to covalent compounds. So we're dealing with covalent naming here. Now, we need to know some Greek prefixes. These prefixes here are used to indicate the number of each atom involved. These are things we need to commit to memory, but you'll notice a lot of those look pretty darn familiar already. So let's discuss our rules, and I bet you that you might know these off the top of your head without even realizing that you do. So first off, we are going to write out the first element and use its entire first name. So let's give ourselves, an example here. Let's talk about the molecule CO2, which we know is carbon dioxide. So in carbon dioxide, we write out the entire first word, which is carbon. But that second one, oxide, we got that by dropping the ending, right? So we chopped off the ending of oxygen. It's no longer oxygen, and we changed it to an IDE ending. So all of these will end with IDE. That's why it's oxide, not oxygen. Now we're also going to use these prefixes that you see up top to denote how many. So you'll notice there are two oxygens. That's why it's carbon di, because di means two, carbon dioxide. Down on number 4, you'll notice that the prefix mono means one, but we only use that on the second element. So the example you see there is carbon monoxide. We don't call this monocarbon dioxide or monocarbon monoxide. Mono is only used on the second element. If there's one of the first element, you just write the element name. And then finally, if you end up with two vowels together, you typically drop that from the prefix. So for instance, CO4 would be carbon tetroxide, not carbon tetraoxide. You'll notice that a lot of these prefixes end with vowels. In fact, all of them do. So if we end up with two vowels together, typically we drop that vowel off of the prefix. We won't be all that stringent with the naming rules in terms of if you have a bad vowel situation. For instance, we would likely let carbon tetraoxide slide. Just know you're not going to see that in everyday life. So let's get some practice writing out these formulas. And before we do, let's just remind ourselves how to actually write the prefix as opposed to the name. So you'll notice that in all of these examples, we're giving you names like dinitrogen pentoxide or iodine trichloride. That order of names also indicates the order of the atoms in the molecule. So if you look down at number 1, what I mean by that is the order given is C then O. So we're going to write out the entire first name of the element, which we said was carbon. There's only one of those, and remember we don't use the prefix mono on the first element. And then we're going to take two oxygens, so we'll change oxygen to oxide, but there are two of them, so we're going to call it dioxide. Now would be a great time to pause and try the remainder of this column if you'd so desire, and then rejoin us. So number 2, again we have carbon. Again, it's by itself, so no prefix, carbon. And then 4, the prefix is tetra. Chlorine becomes chloride. You'll notice that all of these end with IDE. Number 3, again, there's one of the first elements, so we'll leave its name alone. It's just sulfur. Prefix for 3 is tri. And oxygen becomes oxide. In number 4, now we suddenly have more than one of the first elements. So now we do need a prefix to indicate that. You'll notice that hexa is the prefix for 6. So this is going to become hexa, but nitrogen keeps its ending. We only change the ending of the second element, which in this case becomes non, for 9, non-oxide. Again, we change that ending of oxygen to IDE, so hexanitrogen, non-oxide. Again, we have more than one of the first element, so we'll use the prefix penta to indicate 5. This is pentasulfur. Prefix for 10 is deca, so we have deca, and bromine becomes bromide. So you'll notice some things about that list. We have all of these elements with the appropriate prefixes for their numbers. They all end with IDE. They all are in the same order that was given to us. So let's go the other way around, and perhaps this is actually the easier way, right? Because here we're given prefixes, and we just have to convert those into numbers. And so di means 2, and it's 2 of what? Well, it's 2 nitrogens. So we're going to put N2, the number follows the atom. And then pentaoxide, oxide, this ox root definitely means oxygen. So we have oxygen, how many of them? Well, penta, that means 5. So again, if you want to try these ones, feel free, and then pause and come back. If you've paused and come back, number 7, iodine, if it just has the element name, no prefix, that means there's one of them. Trichloride must mean there are 3 chlorines, so Cl3. We probably already know this, but you'll notice that anytime we have an element that is 2 letters long, it always goes uppercase, lowercase, right? You'll not see an element with 2 uppercase letters in it. It's always uppercase, lowercase. Sulfur hexafluoride, be careful with, because sulfur is just S, but fluorine is not Fl, it's simply F, and there are 6 of those from the hexa. Xenon tetrafluoride is Xe for xenon. Tetra means 4. 4 what's? 4 fluorines. And finally, heptaphosphorus decoxide. Well, hepta means 7, so we have 7 of those phosphorus atoms. And decoxide, oxide means oxygen, and there are 10 of those. So there is your covalent naming and our practice problems. We will have a whole unit devoted to ionic naming coming up next.